All right, welcome. In this explainer, we're going to unpack the absolutely amazing story of how our planet was formed. How did it go from just a chaotic cloud of space dust to the organized, layered world that we live on today? So, let's start with a really big question. If you could slice the Earth right down the middle, you'd see it's not just a solid chunk of rock, right? It's got a core, a mantle, a crust. But if you ever really stop to think, how in the world did those layers even form in the first place? To get to the bottom of that, we have to start at the beginning. So here's step one, gathering the ingredients. And for this, we need to go way, way back in time. We're talking about 4.5 billion years ago, to the birth of our solar system.
Okay, so picture this, a huge, swirling cloud of cosmic gas and dust, just hanging out in space. This was all the leftover stuff from when the sun was formed, and it held the raw material for, well, pretty much everything that was about to happen.
Now, very slowly, inside this massive cloud, little bits of dust and ice started to stick together. These first tiny clumps are what scientists call planetesimals. You can think of them like the little pebbles that, if you gather enough of them, eventually build a whole mountain. And this is where gravity really steps up to the plate. It basically became this cosmic vacuum cleaner. See, as these planetesimals got bigger, their own gravity got stronger, and that pulled in even more material, which made them grow even faster. This is what formed the early Earth, or as we call it, the proto-Earth. But here's the thing, this early version of Earth wasn't the cool blue planet we know today. No way. It was a scorching, hot, molten ball of rock. And that brings us to step two, turning up the heat. Let's dig into why it got so incredibly hot. So all this crazy heat came from three main sources. First, you had constant bombardment. A relentless storm of asteroids and comets were just slamming into the planet. Second, there was compression. The massive force of its own gravity was literally squeezing the planet, which generates a ton of heat. And third, you had radioactive heat from elements deep inside the planet that were breaking down and releasing even more energy. So, let's recap. We've got this giant, glowing ball of completely melted rock and metal. At this point, it's all just one big, soupy mixture, which of course leads us to step three, the Great Separation. So what happens now? To really get what happens next, let's think about something super simple, something you probably have in your kitchen right now. A bottle of salad dressing. When you shake it up for a second, the oil and vinegar are all mixed together. But what happens if you just let it sit on the counter? Exactly. The denser stuff, the vinegar, sinks to the bottom, and the lighter oil floats right to the top. They just separate out based on their density. Well, believe it or not, that's pretty much exactly what happened to the molten Earth. This whole process has a fancy scientific name. It's called geochemical differentiation. But all that really means is that the heaviest elements in the mix, we're talking iron and nickel, they started to sink under their own weight, migrating right down to the center of the planet. And that's what formed the core. Meanwhile, all the lighter, rocky materials, called silicates, floated upward. And as this layer of lighter stuff rose to the surface, it started to cool off and solidify. It's kind of like that skin that forms on top of hot soup or pudding. And that process formed the very first solid crust of our planet. So, after all that cosmic gathering, all that intense melting, and that great separation, what are we left with? Well, now we get to step four, the final product, the beautifully layered Earth that we all live on today. And here is that final result in all its glory. Way down at the center, we have a super hot but solid inner core made of iron and nickel. Surrounding that, you've got a liquid outer core. Then comes the thick, gooey, semi-solid mantle. And finally, floating on top of all of that is the thin, brittle crust that we call home. Okay, here's a quick little cheat sheet for you. This table breaks it all down nice and simple. You can see the crust is made of those light silicates, and it's solid. The mantle is denser and kind of semi-solid, like thick plastic. And the core is mostly iron and nickel, with a liquid outer part and a solid inner part. So there you have it. Let's do a super quick revision just to lock it in. Let's run through our recipe for a planet one last time. It really just boils down to these four key steps. First was accretion, that's gathering all the cosmic dust and rocks. Then came the heating, which turned everything into a molten sphere. That led to differentiation, where everything separated out by density. And finally, cooling, which solidified everything into the planet that we know and love today. And that is the incredible story of how our planet got its layers. But here's the thing. The process isn't over.
The mantle is still churning away. The crust is still moving. Which leaves us with a final, really fascinating thought to ponder. Given everything that's happened, what do you think our planet will look like in another billion years?